Now, today we will discuss about how to write the VHDL code for JK flip-flop. I will draw its black box first, how it will be, and then I will come back to you. For this JK flip-flop, I will assume preset and clear are active high. This is the preset. This is the clear. In last case, what I did? In the last case, I will assume this preset and clear are active low. इस केस में मैंने एक्टिव लो एज्यूम किया था, इस केस में मैं एक्टिव हाई एज्यूम कर रहा हूं because you must be aware of everything. And here this clock I'm assuming it is active low or negative age trigger to be exact. This is J and this is K. Here it will be Q and this will be the Q bar. Is it right? This is my aim to write the VHDL code for this kind of the circuit where we have the two terminals JK preset clear and this terminal is a clock. I can give the name as a CLK or CLOCK as per our choice. I have given here CLOCK, that is clock. Now I will discuss how is the truth table for JK flip-flop first and then I will come back to this. If I am writing the truth table for JK flip-flop, it will be something like this. This will be J, this will be K, and this will be Qn plus 1. That is next state. Or maybe the next Qn plus 1 bar will be the complement of this. I will draw only this much. When J is 0, K is 0, we want this next state Qn plus 1 should be same as Qn. This. For 0 and 1, we want or we expect it is reset. For 1 0, we expect it as 1, and for 1 1, we expect its output as a Qn complement, that is Qn bar. This is the truth table for JK flip-flop. Otherwise, I have copied one slide. I will show it to you. Just wait. Yeah, this. Look at this. At the rising edge of the clock or maybe falling edge of the clock for 0 0 Q 0, there is no change. For 1 0, it is 1. For 0 1, it is 1. And for 1 1, it toggles. That is Qn complement. I am trying to mention the same thing. For 0 0, it is Qn. For 0 1, it is 0. For 1 0, it is 1. And for 1 1, it is Qn complement. That is the truth table for JK flip-flop. First, I will start with the declaration part, that is library declaration and then entity declaration and so on. I will start writing the VHDL code. If anyone has any difficulty in between, you can unmute yourself and you can ask the question to me. This is library. I will start with library declaration. Library IEEE. Semicolon. Just wait. Library IEEE. Then another library use IEEE dot std underscore logic underscore 1164.all. This is another library, then semicolon. This part is the library declaration. Now I will start the discussion about the entity part, how it will be. It will start with reservoir entity, followed by name of the entity. The name of the entity I will give it as underscore K underscore FF. JK flip-flop, its name I will give, this is J underscore K underscore FF. JK flip-flop. Is it right? Is. Then we have the port declarations. What are the ports we have? We have one port as a J, another port as a K. The next port is clock. Next port is the preset. Next port is the clear, colon, in, and these ports are available in std underscore logic followed by the semicolon. This is 1, 2nd, 3rd, 4th, and 5th. These 5 ports we have declared it as an input port. Look at this is 1, 2, 3, 4, 5. These are the input ports. Now I will declare its output ports, that is Q, and it is Q underscore bar, Q bar, colon, available as out, and its data type is std underscore logic followed by the bracket followed by the semicolon, and here we have the end of that entity name, which is j underscore k underscore ff. This part is the entity declaration part. Now look at this is the library declaration, this is the entity declaration. Now, after the entity declaration part, I will start with the architecture. How is the architecture? It will start with reserved architecture. Followed by name of the architecture. What is the name of the architecture here? I will use behavioral. Of name of the entity. Already we have given the name of the entity as j underscore k underscore ff. Is. Is it right? Now, as I have discussed in the previous programs, I will just show the flavor and I will come back. Then it will become easier for you to use this VHDL code. Now we are using in the previous case. We are using one temporary signal and everything we are assigning to that signal, and finally the signal value will be assigned to the Q and Q bar at the end of the program. I'm planning to use the similar concept here. Is it right? Now in this case, I will declare one signal temp, or you can give any other name also. Signal temp. Followed by colon, followed by its data type, that is std underscore logic, followed by the semicolon. All the declaration except variable declaration must be before the begin of the architecture. I have completed the declaration. I will start the architecture, that is the begin of the architecture. Is it right? In the begin of the architecture, I'm planning to use the clock. Here I'm using the clock. And this clock is negative age triggered. Look at this bubble. This is negative age triggered. Is whenever my age go negative, in that case it will stop or it will be active. Means I'm planning to use the if statement, and I'm planning to use the if statement, which is the sequential. I have to use the process. That's why after the begin of the architecture, I'm using the process and put the process sensitivity list. In the process sensitivity list, I have J, I have K, I have clock. Then I have preset, that is PRS, I have the clear CLR. This is my process sensitivity list. After this process sensitivity list, I'm planning to use the begin of the architecture. Begin of the process. This is the begin of the process. In the begin of the process, I'm using the if statement. And first, I will define this preset and clear, which are the asynchronous. Is it right? Now look at here. I'm planning to define the preset and clear terminals. I'm planning to define the preset and clear terminals. Now look at here how I will define if preset is equal to 1 then. Now look at what I have done in the previous case. ये दोनों active है at level 1. In the previous case, what I have done, In the previous case, the preset and clear are active low. That's why what I have defined, preset is equal to 0, then temp is something. And clear is equal to 0, then temp is something. Now here in this case, preset and clear are active in the last flip-flop which I have used is a T flip-flop, but for this JK flip-flop, I have assumed it has an active high. That's why if the preset is equal to 1, then this temp is assigned as, preset means set value, temp is assigned as 1. Is it right? Else if clear is equal to 1, then this temp is assigned as 0. Else if, now I am using the clock. Look at here, this is for preset is equal to 1, so temp का value 1 होगा. If the clear is equal to 1, then temp value will be 0. Else if I am using the clock statement here, else if this clock is equal to 0 and clock tick event. Clock tick event, then look at here. This clock is equal to 0 and clock tick event means falling edge of the clock. Clock is equal to 1 and clock tick event means rising edge of the clock. We are discussing about the falling edge of the clock. And here just I will copy this, the truth table. For this I will use another if statement because our clock statement should not have the else clause. इसको else clause नहीं होना चाहिए. Are you getting me? The clock statement should not have the else clause. That's why I am using another if statement. If j is equal to 0 and k is equal to 0, then copy the truth table. If j is 0, k is 0, what should be the temp value? Because I will assign initially to the temp and finally to the qn and qn bar. What should be this value? Temp should be no change. This temp should be same as temp because I am assigning initially value to the signal. That's why this temp will be assigned as temp because it is qn itself. Is it right? It is qn itself. The next, else if j is equal to 0 and k is equal to 1, then if j is 0 and k is 1, if j is 0 and k is 1, what I have defined? If j is 0 and k is 1, qn plus 1 is 0. Or temp is 0 because in that case this is no change, this is reset, this is set, and this is qn complement in that sense. In that case, this temp will be assigned as 0. Else if j is equal to 1 and k is equal to 0, then look at what. For j is equal to 1 and k is equal to 0, the next state will be 1. That's why this temp will be assigned as 1. And finally, else. What should be the value of the temp finally? It is qn complement. That is nothing but temp is assigned as, look at this, this temp will be assigned as, this temp is assigned as not temp. That is complement of the temp. And it will be end if. This is end if. Now look at what I have done. Just I will minimize it so that I'm able to separate out the things. This is right. This is if statement. Look at this part. And this is end if. This is start if, this is end if. And this is my clock statement. I'm not using any else clause because this is the start of the if statement, and that if statement I will end here. I will end here. I will use the end if here. Just wait. I will zoom it little bit so that you may be able to see in the better way. And finally here I will write it as end if. It will be end if. And this is end if of the first if statement. Is it right? After the end if, we have the end process. Here is the end process. And after this end process, whatever the temporary value we have assigned to that signal, those values should be assigned to the Q and Qn complement. This is Q is assigned as temp, and Q underscore bar is assigned as not temp. This is assigned as not temp. And after this end process, we have end of the architecture, which is end behavioral. This is the VHDL code for the JK flip-flop.